everyone. This is part one of a two-part video, which is going to talk about parallel figures and transversals. Prior to starting this video, make sure that you have had an opportunity to review all the different vocab terms used for this chapter. For example, alternate interior angles, alternate exterior angles, same side interior angles, and so on. We're going to go through 4 examples in this video, and then I'll have a couple for you to try at the end. So we're actually going to begin, this is on our parallel and transversal figure note page. I'm going to actually start with number 2 first, then we'll come back to number 1. So the biggest thing in any of these problems is that you need to make sure that you read all the given information and that you are labeling the drawing. So right away, first thing that I'm observing here is that we're given that 2 lines are parallel. All of these new relationships that you've been learning only work when the lines are parallel. So we have AC parallel to FD. So we have that statement. I'm going to use highlighter to always denote parallel line. There's technically a little caret symbol you can use like this if you don't have color, but I think it's nice to use the highlighter for that. Okay, so let's get to the problem. ABE is 6x plus 20, and BED is going to be 4x plus 47. Basically, what you're going to need to do in any of these problems is you're going to have to make a judgment on what relationship do these angles have with each other. In this case, because the lines are indeed parallel, these 2 angles are considered alternate interior angles. And based on our knowledge of these angles, that means that they're going to be equal to one another. So that's going to allow me to be able to say 6x plus 20 is equal to 4x plus 47. At this point, we're going to go ahead and just solve the equation. I'm going to subtract the 4x from both sides. And then I'm going to subtract that 20, giving me 2x equals 27. We're going to divide that by 2, and we're going to end up with an answer here. 27 divided by 2 is 13 and a half. So that's my x. Now, that didn't answer the question. Technically, what they need me to find here is CBE. The good news is CBE is actually just going to end up being supplementary with this 6x plus 20. So I can plug the 13.5 into that. I'm going to multiply that by 6 and add 20 to it. And that's going to give me actually 101 degrees by plugging in x. So that means this, since it's supplementary to it, is going to be 180 minus that number. And that's going to give me an angle here of 79 degrees. That's our first example. Not too bad. They do get a little harder, but we're going to go and talk a little bit more about those types of problems right now. So moving back up to number 1, we have HF, ED, and AC, which are all parallel to one another. So all those parallel relationships that we know will all apply here. Okay, so we have HGB, that's going to be this guy right here, is 4x plus 15. I'm going to zoom in just a little bit so you can see it better. DEB, that's over here, is going to be 3x plus 50. And finally, we have EBC, which is down here, 5x minus 30. Now, some people might look at this problem and say, well, Mr. Fugay, I think this angle and this angle are same side interior angles, so I'm going to set them equal. Or I'm sorry, let's retrace that. These 2 angles are alternate interior angles, therefore I would set them equal. That is incorrect. And the reason why is in order for you to use these relationships, you have to make sure, so I'm going to have to a little bit, sorry guys. Let me fix that. Got sidetracked there. 4x plus 15. Let me throw that highlighter back in there. Okay, the reason why that is that, I'll use another highlighter. This 4x plus 15 is along this transversal here in blue. And this one right here is on a different transversal. So you cannot establish a direct relationship between them. However, the one relationship we can look at, 3x plus 50 and the 5x minus 30. These are what we call same side interior angles. And what we know about same side interior angles is they are supplementary to each other. I can set up an equation to create 3x 50 plus 5x minus 30, and that is going to equal 180 degrees. This is going to help me solve for x, which is ultimately what I need to do in any of these problems. This is 8x. That is going to be 20. And so at this point right now, you're just essentially watching me do a little bit of algebra 1. So we get that. So x, 160 divided by 8 is, my calculator's not on screen, so sorry about that. We're going to end up with x equals 20 as our answer here. That does not answer what GBE is. So now I have to make a tough decision here. They want GBE, this angle right here. Now, this is a little trickier than some of the other questions, hence why we're doing this second. Basically, you need to plug 20 in and figure out in blue what this angle is. Well, the green angle and the blue angle are going to end up creating one whole angle, and that whole angle is on the transversal GB. That means it's going to be equal to the 4x plus 15. So if I plug the 20 into here, I'm going to get 80, I'm going to get 95 total. So HGB is 95. That means that these two angles right here and the star together are going to be 95 when I put them all together. Well, 20 times 5 is 100. 100 minus 30 makes this guy 70 degrees. So that makes this little angle have to be the difference between 95 and 70. In other words, the answer is, oops, not 15, it's 25 actually. 25 degrees is going to be our answer for the second question. So those are two examples so far, and let's go ahead and knock out a couple more. Two more in this video. So we're going to look at number 3. AC, D, F, and GJ are all parallel to each other. So bam, bam, and one more bam. Oops. Now again, I want to note that there are two different transversals here connecting, BE and EH. Now with that being said, we're going to go ahead and label these. So BEH is going to be, where I got to find it, BEH is this whole angle right here, and that is 108 degrees. CBE, find that now, CBE is up here, 55 degrees. Not a lot of algebra here. We have to more or less use our properties. Now the 108 is a combination of both these angles right here. So I'll mark it in red and blue so you can see it for a visual. So that together is 108. The red angle, however, is an alternate interior angle with the 55. So I know this red angle has to be 55 right away. Well, since I know they both add up to 108, I just simply take the difference of those two numbers. And that's actually going to give me 53 for this blue angle. So together they make 108. Now let's start thinking about the questions we have to answer here. FEH, that is going to be this guy right here. So that is going to be supplementary with the 53. You always look for those straight lines when you're trying to make that decision. It's going to make that 127 degrees. EHJ, that's this guy right here. That's actually alternate interior angle with that. That's going to be 53 degrees. The biggest key with doing any of these problems is just to recognize that you need to use those relationships, which you can, again, recap in the previous lesson. And you have to make sure you are able to apply them. The other big thing is please, please, please label your drawing. Use the highlighter for the parallel line so that it helps you see what's going on. Final question in this video is this guy right here, number 4. Going to do again, always label your drawing. MF and AE are parallel. Let's go ahead and mark those as such. GCD is isosceles. So what that means is, and again, little side note here, is that means that two angles are equal to each other. Right. The two angles that are equal to each other are the ones that touch this, CG, which is the base. So CG being the base, I'm going to mark that with red here. The two angles that are congruent are this one right here and this one right here. So one thing I'll note here, and you can write this down, is base angles are equal in an isosceles triangle. Okay, so that's going to be an important fact that we need to use in future problems, so just keep that in mind. 112 degrees for ACG, so let's find that again. ACG, that's 112. All right, we need to find HGD, so that is going to be, it's always hard to find these when you're doing the problems here. So the green angle here is HGD. And finally, the last one I need to find, I'll use blue for this, KGM. So KG to M is right here. Okay, so we have to really start looking at the different relationships. There's all sorts of different routes you can go with this. First thing I observe always are those linear pairs. That's always a quick thing that you can find. So 180 subtract 112 is going to tell me this is 68 right off the bat, which makes this one 68 as well. Let's get a good start. The next thing I do is this red 68 and this green angle are also a linear pair. So once again, I can use that same math to say that this entire angle is 112. That answers the first of my two questions. Lastly, we have KGM. KGM is going to be a little trickier, but we can still manage this. if this angle right here is 112, and I'm out of colors now, let's use the blue highlighter. This angle up here is going to be its same side interior angle. The reason why? They're on the same side of the transversal, and they're in between the parallel lines. So that is going to make this also 68 degrees. You may have also recognized that they're also alternate interiors with 60. Okay. The blue, the highlighted blue, and the red all make a straight line, which is 180 degrees. So we're now just going to take the 180 and subtract the first 68 and the second 68, and that gives this last angle 44 degrees. Now, we went through these examples fairly quickly. I know it's a 10-minute video so far, but in terms of if I went through too fast on something, please feel free to go back and rewind and look at the problem. Lastly, what I'm going to have you do is if you try on the next page, I'm going to have you try number 5. I'm going to have you try number 6, 7, and 8. Please pause the video for this. And I'm sorry, let's backtrack. You're not going to do page 4. And I don't feel like erasing this now. So we're just going to do page 3. My apologies. Page 3, you're going to do number 5 and number 6. So pause this video, and I will have the results for you in about 5 seconds. Here are the answers to the you try examples. So the one thing you want to know about number 5 is I got a decimal answer for x, and when I plugged it in for FEH, which by the way is a vertical angle with 3x plus 18, that's why they're equal, I get 80.25, but we won't want to write it that way. Remember, we talked in this class, we want to write it in degrees, minutes, and seconds. So I took the 0.25, multiplied it by 60, and that's what leads to the 15 minutes. 6 was another tricky question, but I have all the work here color-coded so you can take some time to review it and pause it, of course. The big thing here is the 5y plus 7 and the 4y plus 18 are not equal corresponding angles, and the reason why is that PQ is not parallel to the GM and the AD. So you cannot set those two equal to each other. Rather, you're going to set the two x's equal because they're alternate interior. You get x is 23. And then this 3x plus 29 and this 4y plus 18 are actually supplementary. The reason why is you turn the drawing on its side. This is parallel, this is parallel. That means the 4y plus 18 could technically be called down here because they're corresponding congruent angles, and now that makes them a linear pair. The reason why my work is over here on the left. That concludes video number 1. Go ahead and look at the assigned problems that you have for today. Once you've completed those problems, I will have a second video which goes through a couple more examples. Thank you for watching.